Hello students, I am Subhashish. Today we are going to learn frustum of a cone. Imagine you have a drinking tumbler, the kind you use for your favorite beverages. It is not a regular cylinder but a shape that's a bit like a cone but with the top part cut off. That's what a frustum of cone looks like. Frustums of cones are all around us. They show up in everyday objects like lampshades, decorative pieces, and even in certain architectural designs. Let's discuss about frustum of cone in detail. Learning outcomes. After the completion of this lesson, you will be able to understand the frustum of a cone and its characteristics, the lateral surface area of the frustum of a cone, the total surface area of the frustum of a cone, the volume of the frustum of a cone. Keywords from this lesson are frustum, cone, height, slant height, circular base, curved surface area, total surface area, volume. Now we will learn what is frustum of a cone and its characteristics. A frustum of a cone, truncated cone, is a three-dimensional geometric shape that results from slicing the top portion of a cone with a plane parallel to its base. This sliced portion creates two circular bases, the smaller upper base and the larger lower base, connecting by a curved lateral surface. The frustum of the cone is essentially a cone with its top portion removed. Characteristics of the frustum of a cone. A frustum of a cone has two circular bases, a smaller upper base and a larger bottom base, and these bases are parallel to each other. The lateral surface of the frustum forms a curved surface that connects the edges of the upper and lower bases. The slant height of the frustum is the shortest distance between a point on the upper and the lower base passing through the lateral surface. The height of the frustum is the perpendicular distance between the upper and lower bases. Now we will understand the lateral curved surface area of the frustum of a cone. The lateral surface area of the frustum of a cone is the curved surface of the cone excluding the upper and lower circular base. The formula for calculating the curved surface area of the frustum of a cone is equal to pi into L into R plus R, where L is equal to slant height of the frustum of the cone. That is, L square is equal to R minus R whole square plus H square, where capital R is equal to radius of the lower circular base, small r is equal to radius of the upper circular base. Now we will solve a problem. A cone's frustum has a slant height of 4 cm and a circumference of 18 cm and 6 cm at its circular ends. Determine the frustum's curved surface area. Solution. In this question, they have asked to find the curved surface area. Given slant height of the frustum of the cone is equal to 4 cm. Circumference of larger and smaller circular ends are 18 and 6 cm respectively. We know that the curved surface area of the frustum of a cone is equal to pi L into r plus r. But we need radii to substitute in the formula. They gave the circumference of the circular ends. From that, we can find the radius of the circular ends. Circumference of larger circle is equal to 2 pi r. That is 18 is equal to 2 pi r. R is equal to 18 by 2 pi. That is equal to 9 by pi. Circumference of smaller circle is equal to 2 pi r. That is 6 is equal to 2 pi r. R is equal to 6 by 2 pi. That is equal to 3 by pi. Radius of larger circle r is equal to 9 by pi. Radius of smaller circle r equal to 3 by pi. Now substitute all the values in the formula. That is pi into 4 into 9 by pi plus 3 by pi. By solving, we get pi into 4 into 12 by pi. By simplifying, we get 48 cm square. Therefore, the curved surface area of the frustum of cone is equal to 48 cm square. Now, we will understand the total surface area of the frustum of a cone. The total surface area of the frustum of a cone is the sum of the curved surface area of the frustum of a cone, the top and bottom circular base. So, the total surface area of the frustum of a cone is equal to curved surface area of frustum of a cone plus area of bottom circle base plus area of top circle base. That is pi L into r plus pi r square plus pi r square. That equal to pi L into r plus by taking common we get pi into r square plus r square, where L is equal to slant height of the frustum of a cone, where L square is equal to capital R minus small r whole square plus h square. Capital R is equal to radius of lower circular base, small r is equal to radius of the upper circular base. Now we will solve a problem. Turkish people wear hats called fez, which have a cone like frustum. Find the area of material that was used to make if its radius on the open side is 10 cm, the radius at the top base is 4 cm and its slant height is 15 cm. Solution. In this, they have asked to find the material required to make a cap which is in the shape of a frustum of a cone. So, the cap will be open on one side. We will consider the curved surface area of the frustum of a cone and add one top circular base. Given slant height of the frustum of a cone L is equal to 15 cm. Radius at the top base R is equal to 4 cm. Radius at the open bottom base capital R is equal to 10 cm. We know that the curved surface area of the frustum of a cone is equal to pi L into capital R plus small r, and the area of top circular base is equal to pi r square. Now, the total surface area of cap is equal to pi L into r plus pi r square. Substitute the values in the formula. That equal to 22 by 7 into 15 into 10 plus 4 plus 22 by 7 into 4 square. That equal to 22 by 7 into 15 into 14 plus 22 by 7 into 16. That equal to 22 into 15 into 2 plus 3.14 into 16. By simplifying, we get 660 plus 50.24. By adding them, we get 710.24 cm square. Therefore, the area of material required to make a cap is equal to 710.24 cm square. Now, we will understand the volume of frustum of a cone. Volume is nothing but the total space occupied by an object, or The volume of a frustum of a cone refers to the amount of space or capacity inside the shape. Volume of frustum of a cone is equal to 1 by 3 into pi into h into r square plus r into r, where h is equal to height of the frustum of a cone, capital R is equal to radius of the lower circular base, small r is equal to radius of the upper circular base. Now we will solve a problem. If 14 cm high drinking glass is in the shape of a frustum of a cone, its two circular ends have diameter of 4 cm and 2 cm. Find the glass capacity. Solution. In this question, they have asked to find the capacity of the frustum of a cone. The capacity is nothing but the volume of the frustum of a cone. Given height of the frustum is equal to 14 cm. Diameters of large and small circle of the frustum of a cone are 4 and 2 cm respectively. Radius of large circle is equal to d by 2, that is 4 by 2. That equal to 2. Radius of small circle is equal to d by 2, that is 2 by 2. Which is equal to 1. We know that the formula for the volume of the frustum of a cone is equal to 1 by 3 pi h into capital R square plus small r square plus capital R into small r. Now substitute the values in the formula, that is 1 by 3 into 22 by 7 into 14 into 2 square plus 1 square plus 2 into 1. That is 1 by 3 into 22 into 2 into 4 plus 1 plus 2. By simplifying, we get 1 by 3 into 44 into 7. By multiplying them, we get 308 by 3. That is equal to 102.6 centimeter cube. Therefore, the capacity of the glass is equal to 102.6 centimeter cube. Students, let us summarize what we have learned. A frustum of a cone is a three-dimensional geometric shape that results from slicing the top portion of a cone with a plane parallel to its base. The lateral surface area of the frustum of the cone is the curved surface of the frustum of a cone excluding the upper and lower circular base. The lateral surface area of the frustum of a cone is equal to pi l into capital R plus small r. The total surface area of frustum of a cone is the sum of the curved surface of the frustum of a cone, the top and bottom circular base. The total surface area of the frustum of a cone is equal to pi L into capital R plus small r plus pi into capital R square plus small r square. Volume is nothing but the total space occupied by an object. The volume of frustum of a cone is equal to 1 by 3 pi h into capital R square plus small r square plus capital R into small r. Thanks for watching.